Today we'll talk about the geometry and data analysis section. Now the review of geometry section will cover lines and angles and plane figures such as circle, polygons and complex shapes, and coordinate geometry. When two lines intersect at a point, they form four angles. The point of intersection is called a vertex. So when AB and CD intersect at the vertex P, APC and BPD will be vertical or opposite angles, and BPC and APD will be vertical angles. Now vertical angles are always equal. AB and CD are parallel lines, and EF intersects them at P and Q. When a non-perpendicular line like this intersects two parallel lines, corresponding angles are formed. APE and EQC are corresponding angles, and corresponding angles are always equal. FPB and EQC are alternate angles and they are equal as well. There are mainly two types of polygons that you'll find in the GRE Quant, a triangle and a quadrilateral. Now, there are different variations of a triangle. For example, this is an equilateral triangle where all the sides and angles are equal. This is an isosceles where any of the two sides are equal along with their corresponding angles. This is a right triangle where angle ABC is equal to 90 degrees. And according to Pythagorean theorem, AB square plus BC square is equal to AC square, where AC is the hypotenuse. This is a right triangle where the other two angles except the 90 degree are 45. In this triangle, the ratio of the sides will be XX x root 2, where x is the side opposite to 45 degree angle and x root 2 is the leg opposite to a 90 degree angle. So let's say in a 45-45-90 triangle, the hypotenuse is 2 root 2. And now we can easily find out the length of the other legs. So according to the formula, we have x root 2 is equal to 2 root 2, which means x is equal to 2. So the length of these two sides will be x. Now there is another special triangle, which is the 30, 60 and 90 triangle. According to the Pythagorean theorem, the length of the sides in this 30, 60, 90 triangle are in the ratio of x, root 3x and 2x. Now the area A of any triangle can be given by the formula half into base into height. And in the special case of an equilateral triangle, the area of this triangle will be root 3 by 4a square, where a is the length of each side. These are the special types of quadrilaterals. This is a square with four congruent sides. This is a rectangle where opposite sides are parallel and congruent, and two diagonals are also congruent, and the angles are 90 degrees. In a parallelogram, opposite sides are congruent and opposite angles are congruent. This is a rhombus where all the sides are congruent and opposite angles are congruent. And this is a trapezoid. At least one pair of opposite sides are parallel. Now, area of a quadrilateral is given by A is equal to base into height. So, based on this equation, the formula for areas of the quadrilaterals change accordingly. For a square, A is equal to A square, where A is the length of the sides. You can also calculate the area from the diagonals, since the square has equal length diagonals. So you can write d square by 2. And on this side, on a rhombus, what you can do is the diagonals are different in length, so you multiply them together and divide them by 2. Let's move on to circles. The area of a circle is given by A is equal to pi r squared, where r is the radius of the circle, and the circumference or the distance around the circle is given by C is equal to 2 pi r. D is the diameter of the circle, where D is equal to 2r. An arc is a part of the circumference of a circle. It has 2 endpoints and contains all the points in between them. In this diagram, AC or ABC is an arc. When an arc creates an angle at the center of the circle, the angle is called a central angle. Now this arc can create an angle where the vertex is at the center like this. So AOC is a central angle. And if the vertex is located on the circle, then this is known as an inscribed angle. So APC is an inscribed angle. Now the central angle created by an arc is the double of an inscribed angle created by the same arc. If you want to find the length of an arc ABC, you can use this formula. Length of ABC divided by the circumference of the circle, which is 2 pi r, is equal to the central angle of arc ABC divided by 360. Now in this circle, this is known as a sector, the region bound by an arc and 2 radii. Now the area of the sector is related to the length of the arc and central angle of the arc like this. The ratio of the area of sector and the circle area is equal to the ratio of ABC length and the circumference of the circle. It's also equal to the ratio of the central angle of arc ABC at 360. In this circle, this line is called a tangent. A tangent intersects the circle at exactly one point, the point of tangency, or in this circle, P. If you draw a radius to this point, it creates a 90-degree angle. If a triangle is inscribed in a circle and one side of the triangle is the diameter of the circle, then the triangle is a right triangle. Angle opposite to the diameter is equal to 90 degrees. The review of data analysis includes methods for presenting data, counting methods, probability, and the distribution of data. Today we'll talk about some of the most frequently occurred topics in this set, specifically from statistics. The average of n numbers in a dataset is the sum of those numbers divided by n. If the dataset is evenly spaced, just take the middle number. Median is the middle value of a dataset when the data are arranged in increasing or decreasing order. So, in a dataset of 5 numbers, the median would be the third number, and in a dataset of 6 numbers, the median would be the average of the third and fourth number. Mode is the number that occurs most frequently in the list. Now, in this dataset, the average is 6.2, the median is 7, and the mode is 4. Quartile and percentiles are used to denote the positions of a point in a numerical dataset. Now there are 3 quartiles, the first quartile Q1, second quartile Q2, and third quartile Q3 that divide the data into 4 roughly equal groups. Now Q2 is the median of the set and divides the set in 2 parts. Q1 is the median of the first part and Q2 is the median of the second part. Let's see an example. So in this set of 6 numbers, Q2 would be the median of the whole set. So since there are 6 numbers, Q2 will be the average of the third and fourth term. So Q2 is equal to 2. Q1 will be the median of the first part, which is 1. And Q3 will be the median of the second part, which is 3. And the interquartile range will be equal to Q3 minus Q1, which is 3 minus 1 is equal to 2. One of the most important data distributions is the normal distribution or the Gaussian distribution. It's shaped like a bell and is centered around the mean. Every data distribution has a mean and a standard deviation. Standard deviation dictates how far from the mean the data points typically fall. A small standard distribution means that the data points are clustered around the mean, so the curve is less spread out. And a large standard deviation indicates that the list is spread out widely. In this Gaussian distribution, this is the mean of the distribution. These 2 points are one distribution away from the mean. These 2 points are 2 distributions away from the mean. Since the distribution is symmetric, half of the sample will fall in this part and the other half will fall in this part. 2/3 of the sample will fall within one distribution of the mean, which means in this area. Only about 1% of the curve is 3 or more standard deviations below.